Hi guys, in today's video, we're going to be demystifying C++ strings. So specifically, we have string and we have std string view. By the end of this video, you're going to have clear examples about how to use these in C++ and what the difference is between these two. So before we get started, let's talk about C-style strings. So before C++, we used to write strings like this in C. Okay, so you might not know this, but this is actually a character array. So it doesn't say string anywhere, it's actually a character array. And at the end, it's null terminated, but you just don't see that here, but it's actually null terminated. So there's an extra character at the end to null terminate the string. And this is how strings were done in the C language before C++. The problem is this is fixed size. So you have to allocate enough space before, and you can't overgrow, you can't grow your string. Okay, and there's no way to easily assign greetings to a new variable. Like if you have another variable, you can't just say, you have to actually stir copy. Well, yeah, you have to do a stir copy. Um, so anyways, so C++, the way you do strings is that you have an std string, which is a flexible string class that owns its own content and manages memory for you. Um, and alternatively, have std string view, which is a lightweight view into a string that refers to existing data. So it's kind of like uh, this is like you own the string, and this is like you're just looking at someone else's string. You could think of it like that. So this was actually introduced in C++17, if you're curious, I think. Yeah. So how do we work with std string in C++? So let's come up with an example. Let's say we have an empty string here, and this is the default constructed is just an empty string. You're going to see that in a second. String name Alex. So here's another string called name, and it's being initialized with Alex. And you can do the same thing like this. Hello. Okay, so this is just the assignment syntax. You see, this is very similar, this and this, but this is called the assignment uh, syntax. So now how can we print the strings out? We'll just go like that just to print them out. Okay, let's see the results here. All right, so basically we're printing out name and the string name, and you can see it's Alex, and then we're printing out greeting and the string greeting. Okay, so a few things to note here. Um, what's happening here is that behind the scenes, std string is actually making its own copy of the text Alex. Okay. and you can output it using std cout, and this operator is just literally overloaded to handle std string, so it's really convenient actually. Or you can just do a default construct an empty string like empty above, which holds nothing, and if you check its length it would be 0. So assigning and modifying std strings, you can see that the std string object supports assignment with operator like this, and you can assign actually one string to another. So for example, um, so for example, let's say you have Alex here, and let's say you have std string um, right, so obviously this is just going to print Alex here. So let's just see the results. Okay. All right, what if we do something where we say name equals John. Okay, so we're reassigning the same name variable to a different string literal. We're assigning a different string literal to the same name. So let's see what the result is here. So it's now John. Okay, so you see that the string can easily change and hold different text. It went from Alex to John. Um, and it can also actually be dynamically resized, which is subtle, but it's interesting. So like it's a one, so this is 4 letters and this is 1 letter. And now let's see what happens here. Okay, so actually it was dynamically resized from size 4 to size 1, which is a big benefit of C++ std string. Okay. So basically, if std string doesn't have enough room for new content, it requests more memory from the system and dynamically allocates, and this makes string flexible. It can grow as needed, but this allocation can have a performance cost. All right. So string versus number. This this is pretty basic here, but it might trip some people up. So let's say you have 45 here. This is it a number? This text, what is this? Actually, it's 2 characters. It's a 4 and a 5, and you can't obviously do arithmetic on it. So this is a string. It's like letters. It's letter 4 and a letter 5, or like a character 4 and a character 5. Um, you can actually convert this to a. You can do like you can convert the characters to numbers, like if you do this. But that's we'll talk about that later. You can do that to convert if you want int name as num equals this, and you can do if you want to name as num, if you want to print it out. What's going on here? Okay. You get the number 45, so you can actually convert the letters 45 to the number 45 using str2i, but it's not the subject today. The subject today is about string and string view. So um, all right, let's look at another example here. Alex. look at this example. Look at this example here. So it says my name basically is Alex. If this string is empty, nothing would be shown, but since it's anyways. All right, so basically, how do we get the string length? All right, so we have a variable called name, and we want the length. So we can just do something name has letter count. Let's see how long a string is. Name dot length. Okay, so you just call dot length on the string. So you have a string and you just call dot length. So there's 4 characters in it. Okay, so what if we do name equals A? And now my name has letter count. Let's see how many letters are in it. Okay, there's only 1 letter now. Interesting. So basically dot name returns the number of characters in the string as a size t. You can see right there. It's size t, constant expression, size t. And then we can actually look at the definition here, but yeah, you probably don't want to do that, but you can look at it. Um, how do I see the implementation? Where is this implementation? Return size. Interesting. So size, so length, I guess, is actually just calling size. Yeah. All right. Anyways, let's say you wanna store it as an int. It's size t, right? The variable for length is, you can see it's size t. What if you want to store it as an int? So like you want to say int uh strlen equals name dot length. Okay, let's see if that works. Okay, it actually works. So you can just convert the size t to an int without any issues. I thought you would need to cast it. Actually, I thought you would need a static cast int that. Anyways, that's fine. So let's say you want to get a user input and put it in a string. Um, with something like stdcn. Like this is how you read stuff in, right? So let's see how we do that with the string. It's actually like you have to be careful with this. Um, so let's look at an example here. All right, so we're gonna ask the user to enter his name. Okay, so you would think like, all right, so I want to get the user's input and get his name, right? So you would think this could be a way to do it. So let's see what this actually results in. Let's see what this results in. Or enter your name, Alex, let's say. Enter. Okay, and then it prints it out. All right, name equals Alex. But let's do something a little bit different. Let's say, what's your name? Alex Jones. Okay, whoa, why did it say? And then it went to print my name and it says Alex. So why doesn't it print my name as Alex Jones? Why does it print my name as Alex instead? It's because there's a space. So stdcin stopped at the space after Alex. And it left Jones waiting in the input buffer. So it's still waiting in the input buffer. Um, so how can we solve this? Let's say you want to read in a string input that has spaces in it. Like, what do you do? Well, you kind of just have to know this already, but you have to use std getLine. So basically, you just have to memorize this. You have to, if you need the space to be in the input string from user input, you would say getLine, std getLine, like this. Let's just go here. Okay. Jones. Okay, see how it printed out Alex Jones this time because std getLine um just gets it with the spaces. That's what you use to get it with the spaces. So what's this though? Like std was it's white space. You know, you can guess. It's ws white space. So it's just an input manipulator that consumes any leading white spaces in the program after typing the name, pressing enter. Um, it discards the white spaces before reading the actual text. Okay, let's move on to a next example. So let's do a short example that talks about copying strings. Okay, so std string. Okay, let's do a short example about copying strings. So you have std string s equals hello. So basically what's happening is that std string actually owns the content. So here like 1, 2, 3, 4, 5, 6 characters are being copied into S, and it's not a big deal. But let's say, imagine this example here. You have another function here that says void print string std string stir that takes a string and then prints it. So let's say we want to print a string like that. So we just call um, print string s. Okay, like let's say you want to copy it. I mean, you want to print it out. So string. Say you want to print it out. Okay. Okay. Well, it prints out hello, but let's talk about the runtime. You're not really gonna see that just by looking at the code, but basically what really happens when you call print string is that it's gonna copy s into a parameter stir because it's not passed by reference or address, it's passed by value. Okay, it's passed by value. Keep that in mind when you do it like this. It's passed by value. And imagine if S was huge. So what does pass by value mean? So it's going to be two strings. You actually have two strings in memory. One is called s and one is called stir. And the function prints and prints s and then destroys it. So basically what happens is that s gets completely copied here. So now you have s and you have stir. So you have two different strings in memory. And in memory means like in RAM. So you don't want to have a lot of stuff in RAM. And then it gets printed and then it gets destroyed. Stir, and then you still have S, but this method also finishes, so S also gets destroyed. So for small programs, it's fine, but imagine if you have like a big program, or not a big program, but like if this is like really long, okay, and you have to copy this whole thing every time you want to print it. So now you have two copies of it. You don't want that. So I'm trying to hint at something like guess what's coming next. Try to guess. Okay, if you can't guess, it's string view. Okay, that's the whole point of string view. Basically, the whole point of string view is that it addresses the memory performance issues and you it's like you can look at the original string instead of copying the whole thing and just print it out. So let's just start talking about string view right now before we come back to this example. All right, so let's add string view into the picture. Include string view. All right, let's put it up here so it's like next to string so you can see include string here and then here we have include string view. Let's actually go look at it. Okay, interesting. String view. You can actually look at the string view class if you want basic string view. Okay. All right, so let's proceed with our example of string view. So std string view sv1 hello. Okay, std out sv1. So we're going to print out the sv1 string view. All right, let's see what happens here. I mean, it's pretty obvious what's going to happen. All right, so it's initialized with a literal, as you can see. And yeah. All right, so let's do back to our original example about not copying the whole thing over. So would print view std string view sv sv dot sv. Mhm. So let's say now we have main and we define a string, okay? Not a string view. We're defining a string s and it says print me, so it wants to be printed. Okay. Print view s. Okay, let's say and another print me. All right, so we're gonna print two things. All right. So basically both of these are valid. The std string and the string literal automatically create a string view for the parameters. So no copies of the string are made. So if these were extremely long, it would be much better to here, take a string view, then a string, because you don't have to copy the whole thing over. It just string view just says, okay, what's my original string? And it's like a reference or a pointer, you could say, to that. Okay. Obviously, you can go from string to string view, but you can't go from string view to string. Like a CD string can't implicitly become. A CD string view can't implicitly become a string. You have to do it explicitly. So basically, you want to, let's say you have a string view SV equals not equals string. I am a string view. So you have this, and you want to say std string sv. So you want to initialize this is stir. Actually, it's fine. Let me come up with a different example. So let's say you have std string name equals Alex. Imagine you have this right now, and then you have std string review view equals name view. Okay, so we're defining a string called Alex. No, we're defining a very string variable called name, and we're assigning Alex to it, the string literal, and then we're creating a string view called view, and we're saying view equals name, and we're printing it. So let's see what the result is first. Okay, so view is printing out as Alex. So let's do something different now. Let's say view equals John. So we're changing view from Alex to John. Okay, so the view prints John, but let's ask a question now. What's when I print out Alex, what's that gonna print out as? I mean, sorry, I gave away the answer. When I print out name, it's gonna print as Alex because reassigning the view doesn't reassign the name, obviously. So there you go. Okay, so that's an overview of string view. Let's talk about substrings. Like, let's say we want to, let's look at some other examples about how we can use this. How about that? Let's just look at some other examples. Let's say you have a function that returns string view. You have a function that returns a string view. It's called get truth. and it takes a boolean b. Okay, and it returns b is true or false. So if b is true, you get back a string view that says true. And if b is false, you get back a string view that says false. Expected expression. What's going on? Return. Oh, that. All right. So this is safe because true and false are actually in static memory. So it's fine. Returning one of the functions parameters. So let's say we go have another example here. Let's say we write string view longer string view a string view b. So we want to see which one is longer and return whichever one is longer. So you can do return a dot size greater than or equal to b dot size. Like that. I think that's right. So we're just gonna return whichever one's longer. I wonder if we can do length. Does that work? Yeah, that does work. Okay, that works. So basically, like if the caller passes two strings, it just returns whichever one is longer. All right, so what about substrings? Like, what if you want to see substrings inside of string view? All right, so actually there's two methods inside of string view that I want to talk to you about. So there's one called remove prefix. It takes, I think, an int, and it basically just like removes the first and card. And there's another one called remove suffix, which does the same thing, but for the suffix instead. Let removes last and cars. That's what suffix means. Prefix is the first characters, suffix is the last character. Um, these modify the view itself, not the original string. So that's what throws people off. They're like, how's a string view, actually removing characters from it? It's not. It's just modifying the view to point to a smaller segment. It's not like modifying the underlying string. It's just telling the view like, hey, just pretend we start actually like at a later point than we started earlier when we do remove prefix or with remove suffix. It's like, hey, pretend we stop at a earlier point than we previously thought we stopped at. All right. So summary. STD string. When do we use it? Um, when you need to own the data and modify it potentially. All right. So string view you use when you don't when you have an existing string already and you don't want to copy it all over. I mean, you can accomplish the same thing with a pointer, but string view is good to know anyways. So the problem is, okay, with this, you have to ensure that the underlying data is valid as long as a view is used. It typically means that like std string should not be destroyed or modified while you're using string view, or else you're going to be really confused when you're trying to like use a string view to see a string and it's just like not there because the original string was actually destroyed by something earlier in the program that you didn't even notice. So yeah, that's it, guys. Let me know what you think.